based on redox reaction. Oxidation. Definition: loss of one or more electrons. Other indicators: addition of oxygen, removal of hydrogen. Effects: increase in positive charge, decrease in negative charge. Electron position: electrons appear on the product side. Agent responsible: reducing agent, reductant, it gets oxidized itself. Reduction. Definition: gain of one or more electrons. Other indicators: addition of hydrogen, removal of oxygen. Effects: decrease in positive charge, increase in negative charge. Electron position: electrons appear on the reactant side. Agent responsible: oxidizing agent, oxidant, it gets reduced itself. Analogy: on a number line moving forward towards V, oxidation; moving backward towards V, reduction. Practice questions: oxidation and reduction. 1. Identify oxidation and reduction. Zn plus Cu by Zn squared by Cu. A. What is oxidized? B. What is reduced? C. 1. Identify oxidation and reduction. Reaction. Zn plus Cu squared minus Zn squared by plus Cu. What is oxidized? Zn is oxidized, 0 plus 2. B. What is reduced? Cu squared is reduced, plus 2, 0. C. Who is the oxidizing agent? Cu squared plus, because it accepts electrons and causes oxidation. D. Who is the reducing agent? Zen, M, because it donates electrons and gets oxidized. Top 2. Classify as oxidation or reduction. A. Epiphromite. Oxidation, increase in oxidation number. B. Cl2, Cl mens reduction, decrease in oxidation number. C. MnO square, Mn Freirbas, reduction. Mn goes from plus 7 to plus 2. D. H2O2, O2, oxidation. O goes from minus 1 to 0. 3. True or false? A. Oxidation always involves gain of oxygen. False. Oxidation can also happen without oxygen, e.g. loss of electrons. B. In reduction, electrons are released. False. Electrons are gained in reduction. C. A substance that gets reduced is the oxidizing agent. True. 4. Which is a redox reaction? Why? A. NaCl plus AgNO3, AgCl plus NaNO3. Not a redox reaction. No change in oxidation states. B. H2 plus Cl2, 2HCl. Redox reaction. H0 plus 1, oxidation. Cl, 0 minus 1, reduction. C. BaCl2 plus H2SO4, BaSO4 plus 2HCl. Not a redox reaction. Double displacement only, no change in oxidation states. A. In oxidation, electrons are written on the product side. B. In reduction, charge becomes more negative. C. A substance that donates electrons is a reducing agent. Problems. 1. Elemental state equals 0 rule. Any element in its elementary form has an oxidation number of 0. Examples: Nionids: H2O2, N2, Cl2, P4, Sc, Fe, Na. Emoji. Group 2. Group-wise oxidation numbers. Group 1 alkali metals, always plus 1, e.g. Na pies, K pies. Group 2 alkaline earth metals, always on plus 2, e.g. Ca quid pies, Mg pas. Group 17, usually minus 1 mon, e.g. Cl minors, Br minors, but except in interhalogen Comzi. Emoji. 3. Specific elements. Aluminium, Al, plus 3, zinc, Zdiang, scandium, Sc, vanadium V, usually plus that's 3. Emoji. 4. Oxygen, usually -2 sides. In peroxides, e.g. H2O2, in superoxides, e.g. KO2. With fluorine, more electronegative, plus O2, O2, 2. 5. Hydrogen, with nonmetals, plus 1 with metals and AH. Emoji H-1, H-1. 6. Ion charge rule. In ions, the sum of oxidation numbers of all atoms equals charge on ion. Example, SO frams sum equal -2, emoji take 7. Molecules rule the sum of oxidation numbers of all atoms in a neutral molecule. So example, H2O, H plus 1 times 2, O -2 plus 2 equals 0. 8. Interhalogen compounds. More electronegative halogen, -1. Less electronegative halogen, charge plus 1. Example, in ClF3, F equals -1, Cl equals plus 3. Emoji. Coordinate dative bonds. If donor acceptor in electronegativity, donor equals plus 2, acceptor equals -2. If a donor equals acceptor in En, donor equal plus 2, acceptor 1. Would you like me to create some practice to specify? Let oxidation number of S equal to X, H equal plus 1, O equals -2 plex -8 equals 0. Q2, Oxidation number of Mn in KMNO. Let oxidation 0, 1 plus x plus 4 minus 2 equals 0, 1 plus x minus 8 equals 0, x. Oxidation number of Cl and ClO3. Let Cl equal XO equal minus 2, x plus 3 minus 2 equal minus 1, x minus 6 equals minus 1, x equal plus 5. Q4, oxidation number of Cr and Cr2O and Phlenistia. Let Cr equals minus 2, 2x plus 7 minus 2 minus 2, 2x minus 14 equal minus 2, 2x equals x equals plus 6. Answer Q5, oxidation number of N in NH2-Freisdiner. Let N XH equals plus 1, x plus 1 is plus 1, x. Oxidation state in coordination compounds. To calculate the oxidation state of the central metal in coordination compounds, follow this general process. Step 1. Know the charge on the coordination sphere. The overall charge on the complex ion coordination sphere is either neutral, e.g. FeCN6, positive negative ion, e.g. FeCN Q- or P-, or step 2, assign oxidation states to ligands. A. Anionic ligands usually have -1 charge. Cl-, bar-, inase, Cn-, SCN nanate, thiocyanate, NO2-. B. Anionic ligands with -2 charge. SO for fuerbretidmans, SO3idmans, C2O fuerbiums, oxalate, O-fuerdi, O-fuerimute, oxide, O2 bentonide, peroxide, O2 ben superoxide. C. Neutral ligands, oxidation state equals 0, H2O aqua, NH3 amine, CO carbonyl, and nitrosyl, C2H ethylene. Note, even though they are neutral, their binding affects properties of the complex, but not the oxidation number. Step 3. Apply formula. Oxidation number of metal equals total charge minus sum of charges of ligands. Example 1. FeCN CN's -1,6 equals -4. Let had oxidation state calculation with structures. 1. H2SO5, peroxosulfuric acid, sulfur S equals +6,2, reason. Oxygen atoms are typically -2, and the peroxide link NiOO gives oxygen an oxidation state of -1. The structure shows that sulfur holds its highest oxidation state of +6. Sulfur in peroxo compounds. 2. CrO suaride, chromium pentoxide, chromium, Cr equals +6. Reason chromium is in its highest oxidation state in KRO5, similar to the peroxo compounds. Chromium in a highly oxidized state. 3. K3CrO4, potassium chromate, chromium +5 less reason, potassium +1 and oxygen balance use the compound. Chromium here is +5. Chromium in an intermediate oxidation state. 4. CrO2, chromium dioxide, chromium Cr equals 0, reason, this is a neutral compound and oxygen is typically -2. Chromium must balance out to 0. Chromium at a neutral oxidation state. 5. Br3O brew, bromine oxide, bromine, Br equals +4 and +6. Reason in Br3O side, there are different oxidation states for bromine. Some bromines are +6 straight, while others are 4. Mixed oxidation states of bromine. 6. H2SO FeRD, peroxymonosulfuric acid, sulfur S +6. Reason, sulfur in this molecule is in its highest oxidation state, +6. Sulfur in peroxo state. 7. A2S4OC, tetraoxidosulfuric acid, sulfur S +5 and 0. Reason, this compound shows two different oxidation states for sulfur, with one sulfur at +5 fried and the other at mixed oxidation states of sulfur. 8. Hydrozoic acid H nitrogen N equal +1. Reason, in hydrozoic acid, nitrogen carries an oxidation state of plus. Nitrogen in positive oxidation state. 9. CaOCl2O3, calcium oxychloride, calcium Ca equals like 1, chlorine Cl, oxygen O equals 1, -1. Reason, calcium as an alkali earth metal has +1 oxidation state. Chlorine in this case has +1 and oxygen has its usual -1 in peroxide form. calcium and chlorine in positive states. 10. FeSO iron 2 sulfate, iron Fe equals plus 2 in free SO pre plus in other examples. Reason, in FeSO4 iron has an oxidation state of plus 2, while in other compounds like Fe23 it shows plus 3. Iron in varying oxidation states. Equivalent weight and standard redox behavior of KMNO4. Let me organize and summarize your point. N factor. Acid N factor equals number of H tries ions released. Example H2SO or N equals 2. Base. N factor equals number of OH Nernst ions released. Example A CaOH do glusten equals do equals salt. N in factor equal to charge on cation or anion, redox reaction. N factor, total number of electrons or gained, formula. N sake change in number factor, equals of change in oxidation state, number of atoms undergoing change, and kitneka change, kitneme change. Common oxidizing agent, KMNN for medium. Mn oxidation state changes. N factors under grams, kitneme acidic, plus 7 plus 2, 5, neutral basic, plus 7 plus 4, 3 strongly basic, 7 plus 6, 1. Nash standard reactions of KMO we are found on numbers. 1 with H2S, H2S, S minus 2, S2T, oxidation of S, N factor equals 2. 2 with SO2, sulfur dioxide, SO2, S plus 4, S equals plus 6, N factor equals 2. 3 with H2O2, hydrogen peroxide, H2O2, O2, oxygen is oxidized from -1 to 0,4. With S2O3 fragments, thiosulfate, S2O3 fragments, SO4. Sulfur is oxidized. 5 with Fe5 with Fe quadmise, Fe kmi, Fe pigmise, N factor equals 1. 6 with Fe craftmise, no reaction. 7 with iron minus acidic medium, I minus I2, N equals 1 electron per iodine. 8 with I minus basic medium, I minus IO3 minus N equals 6. Formulate equivalent weight equals molar mass for the N factor. Always remember. N equal kitneka change, kitneme change. In a chemical reaction, gram equivalence of reactants equals gram equivalence of products. This law helps in balancing redox reactions easily. Balancing of redox reactions. Step-by-step process, general method. Step 1, identify oxidation states. Find the oxidation states of atoms undergoing change. Determine the change in oxidation number. Step 2, find N factor Schreiner. Use the formula. N factor equals kitneka change, kitneme change. Write 2 half reactions, one for oxidation, loss of electrons, one for reduction, gain of electrons. Step 3, cross-multiply the N factors to balance electrons. Apply those coefficients to the entire half reactions. Step 4, balance charges. Add H phi or O iners to balance charges, depending on the medium. Never change the reactant coefficient after charge balancing. Step 5, balance atoms, especially H and O, oxygens by adding H2O, hydrogen in acidic medium, add H phi. In basic medium, add OH. Balancing in acidic medium. 1. Follow steps 1 to 3, oxidation number method and N factor crisscross. 2. Balance oxygen by adding H2O to the side fried lacking O. 3. Balance hydrogen by adding H pi to the opposite side. 4. Ensure charge is balanced on both sides. Example, if 4 oxygen atoms are less in product side, add by 4 H2O to product side. That gives 8H, so add 8H must to the reactant side. Balancing in basic medium. Method A, direct OH menons and H2O addition 1. For hydrogen deficiency, add O8 nans. 2. For every 2 OH intends added, balance for 1 H2O on the opposite side. Method B, acidic balancing, convert to basic 1. Balance the reaction as if it were an acidic medium. 2. Neutralize H pi by adding equal number of OH on both sides. 3. H pi plus OH mens H2O, so cancel, adjust water molecules accordingly. Tips to remember? Always do crisscross of N factors for balance. Fix reactant side coefficients after crisscross. Don't forget to balance oxygen and hydrogen based on medium. After final balancing, check atoms and charges on both sides. step using your method, focusing on Kitnika change, domain change, and treating given reaction unbalanced, Cl2 Cl minus plus ClO3 morn. This is a disproportionation reaction. One element, Cl, is both oxidized and reduced. Step 1, assign oxidation states. Cl2, 0, Cl minus 1, reduction. ClO3 menins, Cl equals plus 5, oxidation. Step 2, break into half reactions. Reduction half, Cl2, Cl minus 0 minus 1, change equals 1 per Cl atom. Since Cl2 has 2 atoms, total change equals 2. Oxidation half, Cl2, ClO3O plus 5, change 5 per Cl atom. Total change equal 155. Step 3, crisscross and factor. Reduction change equals 2, oxidation change equals 5, LCM equals 10. So we multiply reduction reactions 5, oxidation reaction 2. Step 4, write and multiply half reactions. Reduction num 5, 5Cl2, 10Cl mirs. Oxidation 2, 2Cl2, 2ClO3 ner. Step 5, add reactions. Total Cl2 used equals 5 plus 2, 7Cl2. So the final unbalanced reaction, tar 7Cl2, 10Cl minins plus 2ClO3 na stand. Step 6, balance atoms in charge. Now we balance. My Cl atom, 7Cl2 equals 14Cl, 10Cl minus plus 2ClO3 minus equals 10 plus 2 equals 12Cl only. So add 2Cl atoms in ClO3 men inside means 2ClO3 mins contains 2Cl, total equals 10 plus 2 equals 12Cl. We need 14Cl, so reaction is correct as 7Cl2 equals 14Cl. Now balance charges and add OH mins and H2O if medium is basic or acidic. Let's assume basic medium. Step 7, oxygen balance. 2ClO3 minus 6O, add 6H2O on LHS. Step 8, hydrogen balance. 6H2O equals 12H, add 12OH on RHS. Final balance disproportionation reaction, basic medium. 7Cl2 plus 6H2O, right arrow 10Cl minus 2,3 now. Titration is a lab technique used to find the concentration of an unknown solution by reacting it with a solution of known concentration. Types of titration. 1. Acid-base titration. 2. Redox titration. Oxidation reduction. 3. Precipitation titration. 4. Complexometric titration. Redox titration. Involves electron transfer. One substance is oxidized, the other is reduced. KMNO4 redox titration example. KMNO4 is a strong oxidizing agent. Reaction with Fe quad in acidic medium, MnO4 squared plus 5Fe2 plus 8H, right arrow Mn2 plus 5Fe queer plus 4H2O. Steps to perform redox titration. 1. Fill burette with KMNO4, purple. 2. Take Phesos4, unknown conc, in a flask. 3. Add dilute H2SO4, acidic medium. 4. Drop KMNO4 slowly into flask. 5. Purple color disappears as reaction happens. 6. Endpoint. Light pink color appears and stays. 7. Use volume and molarity to calculate unknown concentration. Important formula F text to left text 1, N2 text V2, where N equals normality, V equals volume, and text normality equals fraxed molarity times text N factor 1. Or make this equivalent weight equals molar mass text N factor. Combination reaction. Synthesis reaction. Definition: 2 or more reactants combine to form a single product. Example: 2H2 plus O2, right arrow 2H2O. Explanation: hydrogen and oxygen combine to form water. Hummer 2, decomposition reaction. Definition: A single reactant breaks down into two or more products. Example, 2H2O2, right arrow 2H2O plus O2. Explanation: hydrogen peroxide decomposes into water and oxygen gas. 3. Displacement reaction. Definition: one element displaces another element in a compound. Example, Zn plus CuSO4, right arrow ZnSO4 plus C-ation. Zinc displaces copper from copper sulfate. Tasher. 4. Double displacement reaction. Definition: the ions of two compounds exchange to form two new compounds. Example, AgNO3 plus NaCl, right arrow AgCl plus NaNO3. Explanation: silver nitrate reacts with sodium chloride to form silver chloride and sodium nitrate. 5. Redox reaction. Definition: a reaction where oxidation and reduction occur simultaneously. Example, 2Na plus Cl2, right arrow 2NaCl. Explanation: sodium is oxidized and chlorine is reduced in the formation of sodium chloride. X6 combustion reaction. Definition: a substance reacts with oxygen, releasing energy, usually in the form of heat and light. CH4 plus 2O2, right arrow CO2 plus 2H2O. Explanation: methane burns in the presence of oxygen to produce carbon dioxide and water. Neutralization reaction. Definition: an acid reacts with a base to form water and a salt. Example, HCl plus NaOH, right arrow NaCl plus H2O. Explanation: hydrochloric acid reacts with sodium hydroxide to form sodium chloride and water. 8. Precipitation reaction. Definition: two aqueous solutions react to form an insoluble solid, precipitate. Example, Bel2Na2SO4, right arrow BeSO4, text solid plus 2NaCl. Barium chloride reacts with sodium sulfate to form a solid barium sulfate precipitate. Summary in emoji form: combination, decomposition, displacement, double displacement, redox, combustion, neutralization, precipitation. A base for understanding more complex reactions. Fundamental in chemistry and provide a base for understanding more complex reactions.